Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the October-November 2023 Cambridge 9709 Pure Mathematics P1 paper. This is variant 3 of that paper, paper 1-3. And this question here, we've got the equation of a curve given as y equals 2, x to the power of a half minus 1. And we're told in part A to find the equation of the normal to the curve at the point A, 4, 3, giving your answer in the form y equals mx plus c. All right, so the normal to a curve, what does that mean? Now, a curve, supposing the curve is got this kind of shape here, and supposing that's the point A, which has the coordinates 4, 3. Now, the normal to the curve is related to the tangent. So let's draw the tangent to the curve first. So the tangent is a line which just brushes the curve at that point without passing through the curve, and it shares the same gradient of the curve at that point. So the gradient of this tangent at that point is the same as the gradient of the curve at that point. All right, that's the tangent to the curve. Now the normal is a line which is perpendicular to the tangent passing through that same point. So this would be the normal to the curve here, this line, which is perpendicular to the tangent. Okay, so this line here would be the normal. Okay, this is the normal and this is the tangent. Okay, so we want to find the equation of the normal to the curve at this point. Now, the normal to the curve is a straight line. As you can see, tangent and normals are straight lines. So to find the equation of a straight line, we need two bits of information. One thing that we need is a point on the line. We need a point on the line, any point on the line, which we have, which is A, 4, 3, we have that. And the second thing we need is the gradient of that normal. So we need to find the gradient of the normal, I'll call it Mn. Okay, so the gradient of the normal. Now, what we can do, because we know the equation of the curve, is we can find the equation, or we can find the gradient of the tangent at that point, because the gradient of the tangent and the curve are shared at that point. They have the same gradient. So if I find what dy dx is, that will help me to find the gradient function for this curve. So if I find dy dx, that's actually the gradient function for this curve. So dy dx is when you multiply by the power, so it's a half times 2, which is 1, x to the power of negative a half. So you take one, you multiply by the power, and you subtract 1 from the power. So a half times 2 is 1, and then a half minus 1 is minus a half, and when you differentiate a constant, you get 0. So you can say that this is 1 over the square root of x, if you write it in third type of form. So we know that at the point A, we can say x is equal to 4. At the point A, x is equal to 4. So therefore, the gradient of the tangent at A is going to be 1 over the square root of 4, which is 1 over 2. Okay, so which means that the gradient of the normal is the negative reciprocal. When two lines are perpendicular to each other, then the gradients are negative reciprocals. Okay, so if you multiply the gradients together, you're going to get minus 1. So the negative reciprocal of a half was where you change the sign and you write it, the numerator and denominator switched over. So you end up with minus 2. So now we know what we need. Okay, we have, let me just make a bit more space here. So now we have everything we need. I'll just put this over there so that we have a bit more space. Not much space given in this part of the question. Okay, so now I know what I know that the gradient of the normal is negative 2, and I know it goes through the point A. So now we've got, most students do it in a particular way. I'm going to show you both ways, the way I'm trying to push my students to use and the way that they're used to using in IGCSE or from IGCSE. Now the way that I like to use is use the equation y minus y1 equals m times x minus x1. I just like to use this. It makes everything easier for all types of questions. So x1 and y1 are the two coordinate, the points. So you have, that's x1 and that's y1. So you have y minus 3 equals m, which is the gradient, which is negative 2, times x minus the x coordinate, which is 4. So you end up with y minus 3 equals minus 2x plus 8. Okay, and so you end up with y equals minus 2x 2x plus 11. So y equals 2x minus 2x plus 11 is the equation of the curve in the form that they want us to write it in. Okay, y equals mx plus c. Alternatively, we can use the formula y equals mx plus c, and we can just use the point. You can say, okay, we know that the gradient is minus 2 and the point A 4, 3. So we can put, instead of y, the y coordinate, which is 3, instead of m, the gradient, which is minus 2, instead of x, the x coordinate, which is 4, plus c. So we have 3 equals, that's going to be minus 8 plus c. So c is equal to 3 plus 8, which is 11. So therefore, we can say y equals m, which is minus 2, x plus 11. So whichever way you want to do it, that's fine. Okay, so there we have found the equation of the normal to the curve at the point A. All right, so that's answer to part A. Then it says a point is moving along the curve, okay, in such a way that at A, the rate of increase of the x-coordinate is 3 centimeters per second. Find the rate of increase of the y-coordinate at A. So what I like to do here is I like to write down what we have to find, which is the rate of increase of the y-coordinate. That's dy dt. When it says rate of increase, it means with respect to time. So we want to find dy dt. That's what we have to find. Then I like to write down what we're given. Now what they told us is the rate of increase of the x-coordinate. Okay, the rate of increase of the x-coordinate means dx dt. That's what they gave us. So we got to think about what do we have to multiply this by for us to be left with dy dt. Okay, so the first thing is we have to have a y there, so I'm going to put dy. Okay, and we have to be left with the dt. The dx has to be cancelled out, so I'm going to put over dx. So if I multiply dx dt with dy dx, what I'm going to be left with is dy dt, which is what we're trying to find. And we know that dx dt, they told us, is 3. It's an increase, so it's positive, so that's 3 times. And we know that dy dx is given by what we found here, which is 1 over root x. Okay, this is for the same curve. So it's 3 times 1 over the square root of x. And we know at A, okay, at A, we can say at A, x equals 4. All right, so I can say this is going to be 3 times 1 over the square root of 4, which is 3 times a half, which is 3 over 2, and it's in centimeters, okay, per second. All right, so that's the rate of increase of the y-coordinate at A, when it's at A. At that point, at A, x is equal to 4, so we can then replace x with 4 within our expression for dy dt, and we have found the answer to part B. Okay, then for part C, it says at A, the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of the y-coordinate is a constant at 5 centimeters per second. Okay, so at this point, as the point moves down the normal, find the rate of change of its x-coordinate. So now this time we got to find dx dt. Okay, and what they gave us here is the rate of decrease of the y-coordinate is 5. So they've told us what dy dt is. And we got to think about what do we need to multiply dy dt by to give us dx dt. Now we need to have a dx there, all right, on the top, because we end up with dx. There must be a dx there, and the dy has to cancel out, so I'm put dx dy. Okay, so dy dt times dx dy. Now we know what dy dt is. It's a rate of decrease of the y-coordinate is constant at 5, so it's minus 5 because it's a decrease. Because it says decrease, you put minus 5. So dy dt is minus 5 times dx dy. Okay, so now, in this case, it's now changed because it's going down the normal, right? So at the point A. Okay, so it's at the point A, as A moves down the normal. Okay, so at A, the point suddenly changes direction and moves down the normal in such a way that the rate of decrease, okay, as the point moves down the normal, okay, find the rate of change. So it's now moving down the normal, okay? So, okay, if it's going down the normal, then dy dx now has become, okay, instead of being a half as it was before, it's now going to be minus 2. Okay, dy dx is minus 2. Okay, so if dy dx is minus 2, okay, as it's moving down the normal, the gradient that it's moving along is minus 2. Okay, so this is for the normal. Okay, dy dx for the normal, as it is the normal, right? Not for the tangent. So it's the normal, which the gradient is -2. All right. So we want to find dx dy. This is dy dx. So it's -5 times 1/2, or you can say -1/2. All right, because the reciprocal of this is, we want to find the x dy. We're not finding the negative reciprocal. That's already the negative reciprocal of the original gradient. But we want to multiply not by dy dx this time, as we did here. We want to multiply by dx dy, because that's what's going to leave us with what we're looking for, which is dx dt. So we're multiplying by -1/2, okay, because that's the reciprocal of the gradient that I have. Okay, at a, the gradient at a is -2. So the reciprocal of that is -1/2. Okay, so you're going to have -5 times -1/2, which is 5/2, and that's centimeters per second again. Okay, so there's the answer to part C. So it's positive 5/2 because you have minus times minus. All right, and so there's the answer to part C. So in these type of questions, always what I do is I say, okay, I write down what they're asking us to find, the rate of increase of the y. So dy dt. Then I write down what they gave us in terms of the rate. They said the rate of increase of x coordinate is 3. So that means I write down that they gave us what dx dt is. And then you think, what do we have to do to multiply this by to give me that? So I know that I have to end up with a y. So the y, there must be a dy, and I have to get rid of this x. So I must divide by dx. That will leave me with dy dt. Similarly here, same kind of thing. They ask us to find dx dt, the rate of change of the x coordinate. Then you say, okay, what did they give us? They gave us, okay, the rate of decrease of the y coordinate. So that's dy dt. They gave us dy dt. And so what do I have to do to get dx dt from this if I multiply by something? Well, I have to end up with an x. There must be dx on the top, and the y has to go, so I have to divide by dy. That's how I know how to multiply by dx dy. Okay, so that's the answer to this question. All right, and as we're mentioning, the dy dx, the dx dy now, the actual dy dx is not now a half. It's now -2 because it's now moving along the normal, not along the tangent. So that's why it became -2, which you write as -1/2 because we need dx dy and not dy dx. Okay, so I hope that was clear. Okay, that's the answer to this question number 9. All right, from this paper. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from this topic of differentiation from P1 of Cambridge 9709 can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video that will be linked over here. It tells you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.